review. Again, this week, building on our forms discussion this week so far, and talking specifically about validating our input. In the past, with our pop-ups, we looked for an empty string, and we looked for default text. We looked for null values, and we used our operators and range operators to look for conditions that we were checking for. So we've done that part so far, but now we're going to do a little deeper dive this week with regular expressions. And guess what? I brought my own meme this week. Thank you very much. Thank you to Gary Larson. I don't know if you can read this or not. Let me know if you can't read it. Okay, you can read it. Okay. So this guy on a gunfight, about to embark on a gunfight, says, wait till I say draw, and then says, straw, draw a bridge, which might not work out for him. But the whole point is the person on the left is looking for specific input and is challenging its opponent to match the input. That's where this meme is going. So that's what brings us to our discussion today on regular expressions, also known as regex for short. You might be familiar with it already if you come from other programming backgrounds. We'll look at it in JavaScript today. So I'm going to type in the chat here, and you tell me what type of data this is, what information this is. How do you know, Pallav? Phone number. It is an integer. There's dashes in it. How do you know that it's a phone number? The formatting. How about this piece of information? What type of information is this data chunk? How do you know? Use regex to tell. There's an @ sign in there. At could be a mention in a post. Convention. What is a convention, Pallav? Exactly. The @ sign, something, the @ sign, something, and .com. Nair has it. How about this piece of information? What is this data? And how do you know? Postal code for Canada, in fact. But you see, it's the same reason we know. It's because we as humans recognize the pattern of characters. The phone number starts with 416. It's got 10 digits in total, dashes in there. Tells us if we recognize the pattern, it's a Toronto phone number. The @ symbol with letters before and after it, ending in .com, we recognize that pattern as an email address. Same with the postal code. Canadian postal code, letter, number, letter, number, letter, number is the pattern for a postal code. So that's where I'm going with this, is that's what regular expressions let us do. Can you imagine if you were writing validation, if you had to write out all of the Canadian postal codes to check against to see if it was valid, or all of the phone numbers, or all of the email addresses? You couldn't. So that's the problem that regular expressions solve. They let us look for patterns in strings. So we'll get to some code now. So I've got a regular HTML page here, but I'm going to output to the web page now instead of the console or outputs for the most part. Here's my HTML, nothing surprising. And in my JavaScript, we've got our window.onload event to call the page ready function. Inside the page ready function, we're going to go to the document and get the header, and we're going to get an output paragraph because we're going to use those elements for output. And then the first thing I did was set its inner HTML to be data validation with regex. So far, review of JavaScript we've done so far. So a regular expression, or regex, it's a sequence of characters used as a pattern to search with or to validate against. So, does a string match what you're looking for, or can you find what you're looking for in a string? So, working with regular expressions requires two components: the string that you're searching in and or the string that you're looking for. A lot of people use the needle in a haystack metaphor, or matching. Does this thing match that thing in its pattern? So I've created a string, a sequence of characters here we've referred to as a string so far. And we call it a string because it is a string of characters side by side. A capital letter A, lowercase p, it's empty space character, a string of characters held in the variable myTestString. So now we'll create a regular expression. And look at this. Create a variable as usual equals, look at this, the forward slash, text inside of it, and then the forward slash. So it's these two slashes that create a regular expression object. Var x equals slash, slash. That says to the browser, create a regular expression object. That's how it knows. Square brackets is an array, curly braces is an object, forward slashes surrounding a string of text makes a regular expression object. So this is what we're going to test for, and we're going to look to see if we can find this needle in this haystack. In this case, you can see the pattern is capital J, lowercase AVA. This is the pattern we're looking for. In this case, it's a literal pattern. So now I'm going to output to the screen the string of text test plus my test string, which is the variable holding my string of text. And I'm going to call the search method on the string. And I'm going to pass in my regex, which is my regular expression object. So I'm going to search in my test string looking for to match this regular expression, which is just a literal string JavaScript. Now when I refresh the page, oops, I forgot to get rid of this. Look at this, 23. I was asking, is this thing in this thing? And it replied with 23. So hopefully you can guess that if I count from the start, starting at 0, 0, 1, 2, 3, 4, blah, 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 23 is this spot here. So it's returned where, not just yes or no, but where in the string it found that pattern. However, if I change this to lowercase s, lowercase j, it's going to give me -1. You may remember from our arrays index of method, -1 means it didn't find it in here. So to fix this, we can make our regular expression case insensitive by adding the lowercase I after the last slash. These slashes are referred to as delimiters and specify where the regular expression pattern starts and ends. After the last slash, if we put an I, it makes it case insensitive and we get our match again. We're saying ignore case. Otherwise, it will be case sensitive. So now we could make this all uppercase. And it doesn't care. It still finds it because we made it case insensitive. Now that's looking for the needle in the haystack using the search method on the string and passing in the regular expression. More often than not, you're going to use a method of the regular expression to find what you're looking for. And you can see it here. Regex, whatever your regular expression is, .test is the method we will use more often than not when we're looking to match a pattern. And you can see the structure here. Whatever your regular expression is, .test, and then you pass in the value to compare. So again, we've got two things that we need, the thing we're looking for and the thing to look in. So if I uncomment this hunk, I'm creating a variable that's going to hold whatever I get back from my prompt. And then look at this. Inside of here, my regex .test, which is the pattern I just showed. Oh, am I cutting off everybody? Sounds okay to me. All good here. Okay, I think it must be you, Frida. Okay, thank you. So here I'm using the variable holding my regular expression. .test is the method, and I'm passing value to compare, which is what I'm getting from the user. So I'm going to compare what I get from the user to my regular expression, and I've put it inside my if statement, if value to compare. So this test method will return, as you saw up here, true or false. So now if I type in blah, 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 it won't be a match to that pattern. So it won't, this section in here won't go because we didn't meet the criteria. But if I say JavaScript, and again, because I made it case insensitive, please submit a resume. So this is the core of validating with regular expressions. You create a pattern with a regular expression object. And for the most part in your forms, you're going to use the test method on it. The benefit here, you'll see later, we don't have to check for empty string. We don't have to check for default text. We just say if it doesn't match the pattern, whatever it is, null, false, whatever, if it doesn't match the pattern, we can eliminate it there. Now, up here, we're looking for the literal string of Java, what we recognize as the word JavaScript. But regular expressions have a built-in feature called shortcodes that we can use to create our patterns. So here we've got the year. If we said 2016, if you look at that, and if I asked you to describe the pattern of characters, you would say, well, it's a year, and it is 4 numbers. So there are shortcode characters, referred to as meta characters, that we can use to match this pattern of characters. And you can see on the next line below, I'm going to move this out so you can make it a little easier to see. I've got /d 4 times here. So the /d, the backslash, is an escape character. And in this case, /d is saying the pattern of 1-digit character. So you can see here with 4 of these, I'm looking for a pattern of 4-digit characters. I have to get rid of the space because if I don't, it's going to include those spaces in the pattern. But all that to say, whereas this would only match the year 2016, which obviously is, for the most part, obsolete for what we would want in terms of dates, this will match any 4-digit character. So if we wanted to match from now on, or from this year, we could set this as 21, or 20/DD, or for the rest of the decade, 202/D. But all that to say that whatever pattern we're making, this /D is a placeholder for 1 digit. It's a shortcode meta character. The backslash is the escape to say that I don't really want the letter D. It's going to be a shortcode. I want 1 digit. In this case, the pattern is 4 digits, so I have 4 of these. That's for digits. There are other shortcodes as well. \S is a single white space. So if I did this, or wanted that, I could instead do \S to get a white space character. \W stands for a word character. So that could be the letters A to Z, or the numbers 0 to 9, or the underscore character as well. But it would work the same way. We could have /W here, /W for a word character. And a period is for any character. So it could be asterisk, hashtag, any character is what the period represents. But again, you need one of these for each of your characters. So if you had 3 characters after this, like a password, hashtag, exclamation, whatever, then you need one of these shortcode characters to represent its place in this string of characters, this pattern. So we could build our Humber course code pattern you recognize as being HTTP. What's this, 5104? That's the literal string that would only fit this course. So if we wanted all the courses in the first semester, we could have 2 digits here. Or if we wanted any course in this program, it all starts with HTTP and ends with 4 numbers. Or if we wanted any course at Humber, they all start with 4 letters and then 4 digits. So now this regular expression will match any course code at Humber. That's what these short code meta characters do for us. They create a pattern to look for. The other pattern, hopefully you'll see here, is that we've got 4 of these things and then 4 of these things. So regular expressions have mechanisms, code for amounts, for multiples, for numbers as well. In this case, we know we want 4 word characters. So if we use the curly braces, that says, that gives us an opportunity to provide a number of how many we want. So we want a word character, and in curly braces is a 4, so we want 4 of these word characters. Same with the digits. So the curly braces let us specify that we want 4 of whatever the character was that came before the curly braces. So a word character, 4 of those, please. A digit, 4 of those, please. That's the pattern we're looking for. So it's the same as up here, but allows us to specify a specific number of characters. Much easier, much cleaner, and you'll see, especially with Canadian Postal Code or some of the email pattern regex, they can be a mile long. So being able to read them is very important. And as a web developer, having that regular expression literacy is very important for you as well, so that you can read other people's regex patterns and know what it's looking for, the input that it's expecting to receive. So now that we've created our course code pattern, I'm going to send another prompt. Let me get rid of that past prompt. Value to compare. Now look at what I'm doing here. Instead of saying course code dot test, to look for it, look at this exclamation in front. So I'm saying if it doesn't match. So course code is my regular expression. Test is the method I'm calling for the regular expression. I'm passing in the value to compare that I'm going to get from the user. But instead of looking for true, I'm looking to see that it's not true. And then I'll output not a valid course code. So I've got an if-else this time. So code, blah, 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 not a valid course code. HTTP 5104, valid. But again, with Humber, let's do WebD 1010. Completely different program, completely different course, but because I created a pattern, it recognizes that it is a Humber, the pattern of a Humber course code. In addition to the numbers literally this way, there are 3 other characters to indicate how many of the previous characters we should include. So a question mark is looking for 0 or 1 occurrences of the character before it. If you think about the email or the postal code that I typed in, I'm typing it in the chat. This is how we see it, but sometimes we see it like this, and sometimes we see it like this. So there might be a space, there might not. So that would be 0 or 1 spaces. There wouldn't be more than 1. 0 or 1 dashes in between the characters. So that question mark lets us check for 0 or 1 of the preceding character. The plus sign, as you can see here, will check for one or more. So there has to be at least one character. If you think about an email address, you can't have nothing at example.com. You have to have at least one letter. So for that pattern, you could use the plus sign and say word character plus, meaning there's got to be at least one character before the @ sign. The asterisk will check for 0 or more occurrences. So you could have multiple and many, as many as you like, of the preceding character. So before we had the literal number to specify here, but then we've got these 3 extra characters. That's on the wrong side. The question mark, the plus or the asterisk for these variable sort of but specific amounts. Some other features, round brackets and square brackets. So round brackets indicate a grouping of characters in your regular expression. I'm going to show an example in a bit that does that, but you can group a bunch of characters together and consider them as a grouping with the round brackets. We can also use, remember the pipe character here? If we have 2 of those in JavaScript, that's a logical OR. But in regular expression, we can just use one of them to mean OR. So this pattern here, you can see this grouping is either the lowercase n or the uppercase n, which is how Humber student numbers start. And then look at this, /d, so a digit, and 8 of those, please. So this is the pattern for a Humber student number. But I've got a grouping here with an OR inside. And maybe if you had sections, maybe it would be section A or B. So we can specify it with the OR and with the grouping parentheses. The square brackets can define range. So you don't have to list all the values, 1 or 2 or 3 or 4. You can say in square brackets 0 to 5. So that's what this pattern is looking for, the numbers 0 to 5. And you can do it with letters. As you know, with your hex codes for color in CSS, your hex code be 0 to 9, but the letters are only A to F. So we couldn't use a word character in here because it's only the letters A, B, C, D, E, or F. So we can create a range with our square brackets. One more concept to understand in working with regular expressions. Oh, hang on. A to F wouldn't work. Oh, yes, absolutely, yes. Excellent point. So, as you can see here in the comment, as we did with 0 to 5, we could also do A to F like that. There it is, yeah. But again, if we wanted uppercase and lowercase, we would need to put in the I flag at the end there to say case insensitive. But we can do both. One more concept to understand, and that is how it looks for the string. So if we're looking in this case for STOP in uppercase letters, this would match with unstoppable because it would find this pattern inside of this string. Even though there's characters before it and after it, it would say, yep, this is a match. But if we're only looking for stop and not stoppable or unstoppable, then we need to provide more instructions and more rules to our regular expression. So 2 more characters to look at. Let me do this. The first one is the caret, which is Shift 6 on your keyboard. And that goes at the beginning. And that says this is the start of the string. So it would not find a match for unstop. It would still find a match for stoppable, but because we're saying the string starts here, that removes and invalidates any of the characters before it. At the end of the string, we have the $sign. And that signifies the end of the string. Nothing can come after it. So most regular expressions you see will start with a caret and end with the $sign. And if you find things are matching that shouldn't, this is what I would say probably the problem is. So now this regular expression won't match unstoppable. It'll only match stop, because we're saying the string has to start with stop and there can't be anything after it. Before the forward slash. Because if we do it here, we haven't started a regular expression yet. We have to be inside the regular expression after this first slash to say, we're making a regular expression object here, and this is the start. So it is confusing, or it can be confusing, or these are two characters we don't associate with anything else. So here's my mnemonic for remembering. Get ready, it's Professor Dad Jokes time. How to remember: the caret goes at the start, the $sign goes at the end. The caret goes in front of the donkey. It leads the donkey. But in the end, it all comes down to money. You're welcome. I'll be here all weekend. I laugh at my own jokes a lot. Yeah, okay. Thank you. I appreciate that. That's how I remember it. But more often than not, this is how you're going to format your regular expressions. Whatever character is inside of it, you're going to specify start of the string and end of the string. Unless you're looking for stoppable and unstoppable, then in that case, you would remove those limitations. But 95% of the time, you're going to have the caret and the $. So here's an example of a hex code. We've got our slash and slash to indicate our regular expression object. At the start of the string, there should be a hashtag and then a grouping. And the grouping is either going to be a digit or the letters A to F. So here I've got a digit, the pipe for OR, and my range brackets for A to F. So that grouping. And then there's going to be 6 of those. Of course, there could be 3, but in this example, we'll just focus on 6. And then the $sign to say nothing should come after that. The end slash to stop the regular expression pattern of characters. And then the I flag to specify that it can be case insensitive. And then once we've got our hex code, we use our test method and pass in our various input to make sure it matches. Here's an example, a simple example of regular expression. At the start, we're going to have a word character. Here's the plus to say there's going to be 1 or more of those. And then the @ sign, and then a word character, followed by a word character, 1 or more of those, because a domain has to have 2 characters or more. there's the dot, and then .ca is /w/w, but .com is 3. So we're saying one or more of this character after the first character. So here's 1. Here's 2, but there might be 3 or more. $sign to end the string, / to end the regular expression, I to make it case insensitive. So that's regular expressions. It creates a special regular expression object to look for a pattern of characters. It has these shortcode characters to look for digits, spaces, words, or any character. And then we can build our pattern with these shortcodes. If there's multiples, we can specify literally the number of characters that came before it, how many we want. Or we can specify 0 or 1, 1 or more, or 0 or more. We can specify, we can create groupings from our regular expressions with round brackets. We can use the OR pipe character to be the logical OR. With square brackets, we can provide ranges, not just numbers, but ranges of letters as well. And using the caret and the $sign, we can specify and limit the start and stop of our string. And more often than not, we're going to use the test method on the regular expression and pass in the string that we get from our user to see if it matches the pattern that we've stored in our regular expression. If I switch now to our, remember our mailing list from the last lab, for your lab, you just had to make sure these weren't empty. But I've added a regular expression to match the pattern of an email address. So we'll take a look at that right now. The HTML you've seen, I've added a couple of spans, error spans, to continue showed in class. But this is the JavaScript that I want to show you. So we did this before. The name input, if the value is an empty string, that's going to be an error. Similarly, down at my country validation, country input.value is equal to XX. If you remember, I gave that value as the dropdown. So if they haven't selected anything, it's going to return the value XX. So that's how I'm validating my dropdown, by looking for the default value. But for my email, look at this. I've created my regular expression for email, as you saw in the last example. So here's my regular expression. And now, if not email regex.test, here's where I'm passing in the value I got from my user. So I'm comparing my input now to my regular expression pattern. And inside my if statement, I'm saying if it doesn't match this pattern, then do all this validation error business. Otherwise, keep on keeping on. So here's the example of using the regular expression to validate my input for the email specifically. Now, up here, we're just checking for an empty string. But knowing what our database is, if we designed it to hold a varchar of, say, 30 characters, then we could create a regular expression looking for a string and limit it to 30 characters. And we could use that here. And again, we don't have to search for empty string or null or false or default text or anything. If it doesn't match our pattern, then that's all we need to check for. So that's another reason why regular expressions can be so valuable, is it can save a lot of time. And coding lines. In terms of your validation, you don't have to say if this or that or that or that. You can just say, if this don't match this pattern, We don't want it. So that's taking our regular expressions and implementing it into our, using it to validate our form fields, our user input. There it goes. Now validate drop down. And we continue on, knowing that our data is what we want it to be before, if we're going to a database, before going to the database. So that's validating our form fields with regular expressions. But as I mentioned earlier, reading, writing regular expressions is part of your web developer literacy. Being able to recognize what the pattern is that the regular expression is representing. Being able to create your own is really a helpful skill too, although there's lots of tools out there. I've put links in under learning materials that will help you build and test your regular expressions. Beyond that, I use them in my day-to-day as a developer and as an instructor. I download the assignment files from Blackboard, and then I use regular expressions to rename them, because Blackboard creates this name for each file that's so long I can't see your name on the file, because it adds the date and the course and blah, blah, blah. So just as a quick example, I'm going to show you another use for regular expressions. Here's my data. Remember from database, here's the stock items table. So I want to add this to my database, but as we learned this week, I'm going to need to create, if I want to create rows, I have to use an insert statement. So I'm going to take this data, and I'm going to use regular expressions to help me create a insert statement. So I'm using Notepad++ here because I like the find replace feature here better. So I've copied and pasted in. Yeah.
Sorry, I couldn't hear what you are creating. It's just cutting off.
Oh, okay. So here I've got my data from the stock items table, but it's a spreadsheet in Excel. So I'm going to create an SQL insert statement by copying and pasting that data. You can see it's tab separated. And I'm going to use regular expressions to turn this into a insert statement, which we need to use to create rows. So I'm going to bring up my find and replace. So find and replace feature, find will let you, of course, find something. Here it's finding canine, and it's highlighting for me. But replace will let you replace canine. In this case, we could replace all of canine with dog if we wanted to. So that's what the feature does, find and replace. But in this case, if you look down here, we've got search modes, normal, extended, which looks for line returns and tabs, or regular expressions. So I'm going to select regular expressions, and I'm going to look for this. You can't see it here, so I'll keep it over here. But you can see it's the caret, which is the start of the string, and then a grouping, which is any character, the asterisk, which means any number of characters, and then the $sign, which is the end of the string. So what that's finding for me is each row. So if I click on that, find next, you can see that it's finding the row. But what I'm going to do is I'm going to find and replace with the the quotes, because you know each row in an insert statement has to start with parentheses and then quotes around each of the items followed by a comma. So I'm going to find each row and I'm going to replace it with itself plus a parentheses at the beginning and end and a comma for each of the rows. Next thing I need to do is add quotes and commas around the inside of each row. So to fix that, I'm going to now look for the extended family, and I'm going to search for /t, which is a tab character. So for each tab, I'm going to replace it with quote, comma, space, quote, which will be the end quote and the start quote for the things for each item inside of here. So now I'm just about ready to go. The only thing I need to do now is add my insert into statement at the top. And instead of a comma at the end, I'll put a semicolon. So using regular expressions and find replace for the tabs, I've created, this is now an insert statement in SQL. So all that to say that regular expressions are not just for validating your data. That's its primary use. But there's all kinds of uses for it as well for you as a programmer and for handling files and strings of text to make your job, especially repetition, easier. Any questions about that? So moving forward, if you're working with forms, we didn't require it for my lab for time constraints, but moving forward, if you've got a form, you should be validating your input always, but now using regular expressions to check for patterns as well. You can use this to look for malicious code. There's a few special characters that people use to try and inject malicious code into form fields. So you can search for those and eliminate them and sanitize your input as well. Questions, thoughts, concerns? Have you downloaded the code? Take a look at it. Does it make sense? Yes, exactly. Yeah. So if you're looking for files in folders, asterisk.js. Again, asterisk can be any number of characters .js. So asterisk.js is looking for any JS file, and you can do it for .txt, etc., etc. But it's exactly the same principle. It's a pattern of characters, but also using the shortcode characters to represent the digit. You got it. You're putting the pieces together across multiple courses now. Select asterisk, again, means any and all. Anything and everything. You got it. Now you're seeing the patterns in what we're teaching week to week.